So good morning class, this is Tapas Patra. Welcome to another video of Tapas classes. So already in our previous classes we have discussed some important questions of polynomial. Now this is the last class where we are going to discuss few more important questions of polynomial. Then from our next class we are going to start the next topic. Okay. So let's try to solve the first question of today's class, that is find a quadratic polynomial. We need to find a quadratic polynomial whose zeros are reciprocals of the zeros of the polynomial this one. So we have given a polynomial, hence as it is a quadratic polynomial, hence it has two zeros, one is alpha and another one is your beta. Now, according to the question, we need to form another quadratic polynomial whose zeros will be the reciprocal of these two terms. That means the zeros of the new polynomial will be 1 by alpha and 1 by beta. Okay, so let's check how can we solve the question. Now the question is ax square plus bx plus c. Now from this thing, alpha plus beta will be equal to your minus b by a, and alpha into beta will be equal to your c by a. This is a very basic thing. Okay. Now we need to form a new equation, of a new polynomial where the zeros are 1 by alpha and 1 by beta. So we know that to form a new quadratic polynomial, we are using the concept of this x square minus sum of zeros. So here the zeros are 1 by alpha and 1 by beta. So sum of zeros will be 1 by alpha plus 1 by beta x plus product of zeros, that is 1 by alpha into 1 by beta. Okay. Now x square as it is and minus this will give you alpha plus beta divided by alpha beta x, and plus this will give you 1 into 1 1 and divided by alpha beta. Okay. Now in place of x square write it x square. In place of alpha plus beta put minus b by a. So minus b by a, and in place of alpha beta put c by a, and this will be x plus 1 by, in place of alpha beta put c by a. Okay. Okay. Now as you can see that there is a term c by a in both the terms, but here we don't have any c by a. So if we multiply the entire polynomial by c by a, then what we will have? Now multiply this entire polynomial by c by a. So what we will have? Now sir, c by a x square. Okay, and this minus minus will get cancelled, and this will give you b by a x plus, here if you multiply c by a, this c by a will get cancelled, and that will be your 1. Okay, now this is your polynomial. Again, to simplify this polynomial, as you can see, a is there. As you can see, a is in the denominator. So again multiply this thing as a. So what we will have as our cx square plus bx, and if you multiply this with a, you will have a like this. So this is one way where you can solve this question. So we have already discussed one method where you can solve the question and you will have your answer like this: cx square plus bx plus a. Okay, this is the new polynomial. Let's try to solve this in other way. So if you solve this question like this, x square and minus minus will give you plus. This is your b by a and c by a. This a will get cancelled, and that will give you b by c x, and this will give you a by c. The reciprocal of c by a, that will give you a by c. As you can see, c is here. So you may multiply the entire polynomial with c, and you will get cx square, and now the c will get cancelled, that will give you bx, and here if you multiply this with c, you will get a. So here also you are getting the same result which you got previously. Okay. Question number 56 is there. Verify 2, 3 and 1 by 2 are the zeros of the polynomial this. Again, this is a cubic polynomial and this is not important for your board exam for now. So let's leave this question. Now question number 57. if the sum and product of the zeros of the polynomial this are equal to 10 each. That means sum is also 10 and product is also 10. Okay, the sum and product both are 10. Find the value of a and c. Now again, let's try to solve this question, sir. Ax square minus 5x plus 3. Now if I want to find alpha plus beta, that is the sum, so this will give you minus b by a, so minus and b is your minus 5 and divided by a. Alpha plus beta is 10, sir, so that will give you minus minus plus 5 by a. Now if we cross multiply this thing, then you will have 10a is equal to 5. Now a will be is equal to 5 by 10, that will be your a is equal to 1 by 2. So this is the first. Second, for c, you may do this thing, alpha into beta is equal to c by a. Okay, now so alpha into beta is given 10. We don't know the value of c, but we got the value of a as 1 by 2. Now if you multiply this 1 by 2 to the left hand side, then that will be your 10 into 1 by 2, and that is equal to c. Now this 2 will get cancelled and the value of c will be 5. So here the value of a is 1 by 2 and the value of c is your 5. Okay, so this is an easy question. So I hope you can solve the question. Let's move to the question number 58. In question number 58, it is given that if one of the zero of a polynomial is 7 times the other. So again look at this question. We know that there are two zeros, one is alpha and another one is beta. But in this question it is saying that one of the zero, that means alpha, or you may take beta, is 7 times the other. That means if one zero is alpha, the second zero will be 7 times of alpha, that is 7 alpha. Okay. Now in this question, let's try to solve this. So the question is given that 3x square minus 8x plus 2k plus 1. Now as you can see that this is your quadratic term and this 3 will be your a. Yes or no? This is your linear term, hence this minus 8 will be your b. And this entire term is your constant term, hence it is your c. Okay. Now, if we solve this question, so we have the basic formula alpha plus beta is minus b by a. But here alpha is the alpha and in place of beta you may write 7 alpha. Minus is there, b means minus 8 and a means your 3. Okay. Now alpha plus 7 alpha will give you 8 alpha and that is your minus minus plus 8 by 3. So alpha is equal to 8 by 3 and this 8 will go to the right hand side and will be divided here. So this will be your alpha is equal to 1 by 3. Similarly, if we do the next thing, that is alpha into beta. So alpha into beta is your 2k plus 1 divided by 3, okay, which is your c by a. Now in place of alpha and beta, we can write alpha into 7 alpha and that is your 2k plus 1 by 3. And this is your 7 alpha into alpha, alpha square, and that is your 2k plus 1 by 3. Now the value of alpha is already found to be 1 by 3. So this will be 7 into 1 by 3 whole square. And that will give you 2k plus 1 by 3. Now if you solve this thing, you will get 7 into 1 by 9. And that is 2k plus 1 by 3. Okay. Now if you simplify this thing, let's move this 3 to the left hand side. So this is your 7 by 9. And now this 3 will go to the left hand side and get multiplied and this will be your 2k plus 1. Now 3 will get cancelled with 3 and you will have 7 by 3 and this is your 2k plus 1. Now 2k will be is equal to 7 by 3 minus 1. Now this will be your 4 by 3. This 3 will multiply it with 1 and that will give you 3. The 7 minus 3 will be 4 by 3. That is your 2k. The value of k will be 4 by 3 and this 2 will be divided, hence 2 times 2, that will be 4 and the answer is 2 by 3. Here the answer is 2 by 3. Okay. So I hope this question is clear. It is a little bit lengthy question. At first we have to solve the alpha plus beta is equal to minus b by a. So from here you will get the value of alpha and then put it in the next equation, that is alpha into beta. Okay, so if you put it here, you will get the value of k. Okay, I hope this is clear. Now let's move to the question number 59. Quadratic polynomial this has zeros as alpha and beta. Okay, so we have a quadratic polynomial this where the zeros are alpha and beta. Now form a quadratic polynomial whose zeros are 3 alpha and 3 beta. So okay, already we have a quadratic polynomial like this, 2x square minus 3x plus 1. And here the two zeros are alpha and beta. So there are two ways to solve this question. First thing, at first you need to find the alpha and beta from this polynomial. Then multiply 3 with them and you will have your 3 alpha and 3 beta. Okay, after getting 3 alpha and 3 beta, form a new polynomial. This is the first thing. Or you may find alpha plus beta here and alpha and beta here and directly apply that to the next question. So we will try both the way. Whichever is suitable for you, you may go through that. The first thing, I am trying to find alpha and beta from here. So by using factorization method, I can write it 2x square and minus 2x and minus x. Okay, minus 2 and minus 1, that gives you minus 3, and minus 2 into minus 1, that will give you 2. Okay, 2 into 1, 2. So from this thing, taking 2x common, you will have x minus 1. From this thing, minus 1 common, x minus 1. Now this x minus 1 is there, and this is your 2x minus 1. And to get the zeros, equate it with zeros. So the value of x is 1 from the first thing, and the value of x is 1 by 2 from the second thing. Now we have alpha is your 1 and beta is your 1 by 2. Now to get 3 alpha and 3 beta, the 3 alpha will be your 3 into 1, that is 3, and 3 beta will be your 3 into 1 by 2, that is 3 by 2. Okay, so now new equation or new polynomial will be x square plus x square minus 3 alpha plus 3 beta x plus 3 alpha into 3 beta. Now if you put the value of 3 alpha and 3 beta, you can see that x square minus, in place of 3 alpha 3, in place of 3 beta 3 by 2 x, and plus 3 into 3 by 2. Now if you solve this thing, then you will have 3 times 2 6, 6 plus 3 9, 9 by 2 x, and from this thing again 3 into 3 9 and by 2. Okay, now if I simplify this thing, as you can see there is a 2 in the denominator, so multiply this entire polynomial by 2, so we will get 2x square minus 9x plus 9. So this is the required polynomial. So this is the first way where you can solve this entire polynomial individually and get the answer. There is second way or alternate way where you can try to do it in a convenient way. So let's check this method also. Here sir, alpha plus beta will give you 3 by 2 and alpha into beta will give you 1 by 2. Okay, so this is clear to you. Now the new polynomial will be like this: x square minus 3 alpha plus 3 beta x plus 3 alpha into 3 beta. Okay, now which we have already written here. Now x square is there, leave it, minus, taking 3 as common, you will have minus 3 into alpha plus beta x, and from here 3 into 3 will give you 9 and alpha into beta will give you alpha into beta. Okay, na? Okay. So x square minus 3 into alpha plus beta is your 3 by 2, so put it here, plus 9 into alpha into beta is your 1 by 2, so put it here. Now you have x square minus 3 into 3 will give you 9 by 2x plus 9 into 1 gives you 9 by 2. Now again you have left, or again you have the polynomial where 2 is in the denominator. To simplify this, let's multiply this with 2. This will be 2x square and here 9x and plus 9. So you can see that in both the cases you get the right answer or the same answer. Okay? So there are two ways whichever is suitable for you, whichever is easier for you, you may follow that method. Now question number 60. If alpha and beta are the zeros of the polynomial this, then find the value of alpha square plus beta square. Easy one. Alpha plus beta will be your 4, as it is minus b by a. So b is minus 4. So minus b is plus 4 and a is 1. So it is 4 by 1, that is 4. And alpha into beta is c by a. So c is your minus 5 and a is your 1. Okay, now we need to find the value of alpha square plus beta square. This is nothing but alpha plus beta whole square minus 2 alpha beta, right? Then place of alpha plus beta, put 4 square minus 2 into alpha plus beta, alpha into beta is your minus 5. So 16 plus 2 into 5 will be gain. Now this is your 26. So the value of alpha square plus beta square will be 26. Okay. Now let's move to the question number 61. Here, find the quadratic polynomial. The sum and products are given that minus 3 and 2 respectively. Hence, find the zeros. So first we need to form a polynomial. Then we need to factorize this and get the zeros. Okay. Now? So let's try to form the polynomial. So it's very easy. X square minus alpha plus beta x plus alpha into beta. X square minus alpha plus beta is already given you minus 3 and alpha plus beta is already given as 2. Okay na? So if you ask me this question, then I can say that this is minus 3, that means minus 2 and minus 1 are added and you get minus 3, and minus 2 and minus 1 get multiplied and you get plus 2. So the zeros are minus 2 and minus 1. Okay. So after solving so many questions, you will acquire such kind of knowledge that just seeing the question you can get the answer. Okay. So minus 2 and minus 1 will be the answer, but try to solve this thing. So what will happen, sir? Now in this question, this will be x square plus minus minus 3 minus minus plus 3x plus 2. Now if we now the polynomial is this one, x square plus 3x plus 2. Now if you try to factorize this thing, then x square, this will be your 2x plus x, 2x and x will give you 3x, and 2x into x multiplied with, and that will give you 2. Now taking x as common from this, you will have x plus 2, and there is nothing common in between them, so taking 1 as common, you will have x plus 2. Now in both cases, you have x plus 2 as common, so you will have x plus 1. So to get the values, let's take it as 0. So from this thing, you will get x plus 2 is 0. Hence, x is equal to minus 2. From this thing, x plus 1 is 0. So x is equal to minus 1. So again, you may see that you get the same answer, that is minus 2 and minus. Let's move to the question number 62. So in this question number 62, what is given to us? Now find the zeros of the quadratic polynomial, this one, and verify the relationship between the zeros and the coefficient. This is a very important question from the class 10th point of view. Okay, now this question carries 3 marks. Okay, last year also there is just such kind of question in the board exam. So all of you pay attention here. At first, what we have to do is that we need to find the zeros, and after that we have to verify the relationship. Relationships, we have two relationships, that was alpha plus beta is minus b by a, and another is alpha into beta is c by a. Whether you are getting the right relationship or not, you have to check it. Okay. So the polynomial is 6x square minus 7x minus 3. Now you may wonder why I write like this. Because the polynomial is given in such a way that you may get confused. You may see that this as your b and this as your c, but not like that. Always arrange your quadratic polynomial in such a way that first the quadratic term, and second the linear term, and thirdly the constant term should be there. Okay. So now here a is your 6, b is your minus 7, and c is your minus 3. Okay. So in this quadratic polynomial, let's try to factorize this thing. So here, if we multiply these two terms, you will get minus 18. And if we add these two terms, you are getting minus 7. So 18 is nothing but your 9 into 2. Okay. Na? So 9 into 2 will give you 18. But here, what do you need? Minus 18. So this will be minus 9 and 2. And if you add this minus 9 and 2, you will get minus 7. So 6x square, in place of minus 7x, I write it minus 9x plus 2x. And where I get this minus 9 and plus 2? Now this is the thing. Now we have left with minus 3. Now taking 3x common, so we'll have 2x here. 3 into 2, 6, x into x, x square, minus 3 is there. And there is nothing common in between 2x and minus 3. So taking 1 as common, we are left with 2x minus 3. Now in both the cases, we have 2x minus 3. So here we have 3x plus 1. To get 0, we have to equate this polynomial with 0. Now 2x minus 3 is 0. That means 2x is equal to plus 3 and x is equal to 3 by 2. From this thing, 3x plus 1 is 0. That means 3x is equal to minus 1 and x is equal to minus 1 by 3. So we have our two zeros. One is your alpha is 3 by 2 and beta is your minus 1 by 3. Now let's try to find out alpha plus beta. Now this will be your 3 by 2 plus minus 1 by 3. Now if you remove the bracket, then this will become your 3 by 2 minus 1 by 3. Now if we try to subtract, then 3 times 3 will give you 9, minus 2 times 1, that will give you 2, divided by 2 into 3, that will give you 6. 9 minus 2 will give you 7, and that is divided by 6. Okay, now then if we try to find out alpha into beta, then this is 3 by 2 and this is multiplied with minus 1 by 3. Now this 3 and this 3 will get cancelled and this will give you minus 1 by 2. Okay, now? So we found the left hand side. Now let's check for the right hand side. Now if I try to find out minus b by a, then what will happen, sir? Minus, and b is your minus 7. As you can see, minus 7 is here. So minus 7. And a is your 6. Okay. So what will happen, sir? Minus minus will give you plus and this is 6. Now if you check, the value of alpha plus beta is 7 by 6 and the value of minus b by a is also 7 by 6. So from here we can say that alpha plus beta is equal to minus b by a. ठीक है ना बेटा? Similarly, let's try to find out c by a. What is this, sir? Now in place of c, we have minus 3 here. So put it minus 3. And in place of a, we have 6. So if we get cancel them, then you will have minus 1 by 2, which is equals to your this one. That means this is your alpha plus alpha into beta. So alpha into beta is equal to c by a. So whatever formula or whatever relation we found previously, we just verified them with this example. So you have to write verified. So I hope this question is clear. In this question, at first you need to find the zeros of the polynomial. Then you need to find alpha plus beta and alpha into beta. Then you need to check whether this is equal to minus b by a and c by a or not. Okay. Always remember that always they will be equal to each other and your answer will be verified. Okay. Now? Okay. Now let's move to the question number 63. If the zeros of the quadratic polynomial these are 2 and minus 3, two zeros are given to you, then find the values of alpha plus beta. Okay, beta. For now, for this time being, let's forget this polynomial. Just construct or just form a polynomial whose zeros are 2 and minus 3. So if we have two zeros 2 and minus 3, then the polynomial becomes x square minus 2 minus 3x plus 2 into minus 3. Right now? Okay. Now this will be x square minus 2 minus 3 will be minus 1 x and 2 into minus 3 will be give you 6. So x square minus minus will become plus x and minus 6. So this should be the polynomial. But according to question, this is equal to x square plus a plus 1x plus b. Now if we compare these two things, you can see that x square is equal to x square. In place of a plus 1, there is only 1. So a plus 1 will be is equal to 1. So a will be 1 minus 1 will be 0. And in place of b, you can see that minus 6 is equal to b. This is very clear that b is your minus 6 and a is your 0. Okay, question number 64 is there. If alpha and beta are the zeros of the polynomial this, find a quadratic polynomial whose zeros are 1 by alpha and 1 by beta. Polynomial, let's try to do this thing in this way. We have a polynomial like this, 6y square minus 7y plus 2. This is the given polynomial. Here the zeros are alpha and beta. So you can see that alpha plus beta will be your 7 by 6 and alpha into beta will be your 2 by 6. Now this 2 by 6 will get cancelled and gives you 1 by 3. Okay, this is clear. Now we need to form another polynomial where the zeros are 1 by alpha and 1 by beta. So this will be the new polynomial where the zeros are 1 by alpha and 1 by beta. Now this will give you x square minus, this will be your alpha plus beta or beta plus alpha, both are same thing, and this will give you 1 by alpha beta, right now. So x square minus alpha plus beta will give you 7 by 6 and alpha beta will give you 2 by 6. X plus 1 by alpha beta is your 2 by 6. ठीक है ना? Now here this 6 will get cancelled. This will be x square minus 7 by 2x and this will be, the reciprocal is 6 by 2. Now you can clearly see that these two denominators, these two terms contains a denominator 2. So to remove or to eliminate this, we have to multiply this entire polynomial by 2. So we have 2x square minus 7x plus 6. Okay. Again, there may be another method where you can solve this entire polynomial and find alpha and beta. ठीक है ना? After that, you may find 1 by alpha and 1 by beta. Then you may solve it, or then you may form a new polynomial where these are the zeros. Okay. There are two ways, whatever is suitable for you. I think this is a better way, so I go through this way. If you want, you may go through in this way also. You will also have the same answer. Now we'll have two more questions and after that we will end up the class. The first question is that find the zeros of the quadratic polynomial this and verify the relation between the zeros and coefficient of the polynomial. Just before this we have already done this thing. Again let's try to do this thing. So 5x square plus 8x minus 4. Okay now, as we have already done this, so I am doing it in a speedy manner. So what will happen, sir? Now if you multiply, the answer will be 20 and if we join or if we add, the answer should be 8. Okay na? So clearly you can see that one number is 10 and another number is 2. So this is plus 8, so 10 minus 2 will give you 8 and 10 into 2 will give you 20, which is equals to 5 into minus 4. Okay, so from this taking 5x as common, you will have x plus 2 and from this taking minus 2 as common, x plus 2. Now both the terms have x plus 2 as common, so we will have 5x minus 2. Get to take to get 0 of the polynomial, equate it with 0. So from this x is equal to minus 2 and from this x is equal to your 2 by 5. So here you get your alpha is minus 2 and beta is your 2 by 5. So alpha plus beta will be is equal to your minus 2 plus 2 by 5 and that will be your 5 into 2 minus 10 plus 2 by 5, which is equal to your minus 8 by 5, right? Now if we arrange it, so you can see that this 8 is nothing but your b, right? And this 5 is nothing but your a, so you can write it like this. So from this thing you can see that alpha plus beta is equal to minus b by a. So if we want to find alpha into beta, then alpha is your minus 2 and beta is your 2 by 5. So if I multiply this, this will give you minus 4 by 5. Now this minus 4 is nothing but your c. This is your c. So in place of minus 4, write down c. And this 5 is your a. So you get that alpha into beta is equal to c by a. And hence verified. Okay na? Now we have the last question, that if alpha and beta are the zeros of the quadratic polynomial such that alpha plus beta is 24 and alpha minus beta is given that 8. Find the quadratic polynomial having alpha and beta as its zero. So till now we have alpha plus beta is there and alpha into beta is there. So by using these two terms, we can form the quadratic polynomial in this manner, right now. But in this question, alpha into beta is missing. We only have alpha plus beta. So at first, our job is to find alpha into beta. Then using it, we can form the new polynomial. Okay. So first thing is we have to find out alpha plus beta. So how to do that, sir? Now there is a very beautiful relationship in between alpha plus beta whole square and alpha minus beta whole square, which we have already discussed in our previous classes. Now, in place of alpha plus beta, the value is 24. So this will become your 24 square. In place of alpha minus beta, this is your 8 square. And this is your 4 into alpha beta. Now 24 square will give you 576 and this 8 square will give you 64 and this is your 4 alpha beta. Now if you subtract these two terms, you can see that 6 minus 4 will give 2 and 7 minus 6 will give 1 and 5 1 2. That is your, now for alpha into beta is 5 1 2 divided by 4. So 4 times 1 4, remaining 11, 4 times 2 8, then 4 times 8 32. So alpha into beta is your 128. Putting the value of alpha plus beta and alpha beta in this polynomial, you will have x square minus alpha plus beta is your 24x and alpha into beta is your 128. Now this will give you x square minus 24x plus 128. Okay, beta. So with this, we have completed around 50-60 questions of the polynomial chapter. I hope this is more than enough for your board exams. Okay, so if you have any problem or if you have any doubts, you may ask me in the comment section and I will try to reply it. So with this, I would like to conclude today's class and thank you all for being attentive.